All right, so let's move on to uh, one of our reactions called a double replacement reaction. Now, arguably, between this and combustion, these are the two hardest reactions you'll have to deal with because there is a lot going on depending on what the teacher or professor asks you to do. All right, so our general equation for a double replacement reaction is going to be AB plus CD in terms of alphabeticity, if you wanted to view it like that. And this can also be a double displacement, and the definition is either one of these molecules can switch with each other, but they're just doing a little switcheroo. Okay, so we get something like AD plus, or sorry, or never mind. Okay, we get AD plus CB. Okay, they're just doing a little switcheroo. It's kind of confusing for students to wrap their head around this, so I'm going to try to make it as simple as possible. Not all double replacements will produce a reaction, but all of the rearrangements are feasible, or real compounds. And we'll get to that no reaction stuff later. There are certain rules and conventions you have to follow. All right, so for our first example, we take silver nitrate, which is soluble, and we combine this with sodium chloride, which is also aqueated, and out comes silver chloride, and silver's in the one state here because it's in the +1 state as well. And then we have sodium nitrate. Well, silver chloride is, we'll talk about precipitates later, but silver chloride will be a precipitate. And then our sodium nitrate will be our aqueated. All right, now let's get to the assigning the numbers and the whole shebang. Okay, let's do our convention here. Remember, nitrate's a polyatomic ion, which has negative charge. So one nitrate, one sodium, one chlorine, one silver, one chlorine, one sodium, and one nitrate. Okay. So the reason I did this, I made it so that way it's balanced because I want you guys to see what happens. So what we have here is that this cation, if we look in the perspective of this cation, it remains, and then chlorine from the sodium chloride comes and adds onto the silver. This cation remains. The chlorine comes off of the sodium, and then the sodium binds with nitrate. Now it could be the other way around, with chlorine replacing nitrate, and that's usually how we write things. So let's get to an equation where we actually have to do some balancing. Okay, so right here we have iron 3 oxide. And remember, iron in the 3+ state is the most abundant. And we add this to aqueated hydrochloric acid, which is always aqueated, unless it's a gas. And then out comes iron 3 chloride plus water. So let's write out the atoms as per our convention. Okay, so this is a mess, okay? None of these atoms are balanced yet. So as a general rule, let's just start with the hydrogens, or the lowest atomic mass. Okay, in no particular order. You can do at one end of the extreme or the other end of the extreme. It doesn't really matter, but let's just start with hydrogen. Okay, so you can see here, we need one more hydrogen. So you multiply that by a factor of 2, or yeah. Okay, now chlorine changes. So we got chlorine here, and this is the tricky part that most students struggle with. You can cross multiply, but the thing is we already have a 2 here, so you got to keep that in mind. So we do 3 times 2, okay, and then we get 6 here. So then hydrogen changes to a 6, and chlorine changes to a 6. And we cross over here. Remember, we had a 2 over here, so then we put a coefficient of 2 in the iron, and then we get 2 irons and 6 chlorines. Okay, and then we have 2 more things we need to do. one, we need to balance the hydrogen here and the oxygen here. However, in that little eureka moment where we can just write a 3 here, this will change the hydrogen to 6, and that's why I changed the oxygen to a 3. All right, now everything is balanced, and there is your double replacement. Now, in the next video, we're going to be going over a lot of complicated concepts when it comes to assigning these molecules their respective states of matter. And it's difficult because you have to involve multiple factors of solubility rules, and then the scale of there's like the scale of cations and all of that. And yeah, we'll be going over that in the next video. So not to fret there. Thank you guys for watching, and I will see you in the next one.